All right, so first one we'll, well, that didn't do us any good, did it? We'll tackle this one. We'll move this down, and then we'll tackle this one by itself. All right, so we're finding dy dx. This, to do that, this is implicit differentiation. This is what we were working on last time. So for the first one, you got xy. That's the product rule. The derivative of the first is 1 times the second, which is y, plus derivative of the second, which is dy dx, times the first. So this is x times dy dx, plus 2y, and then we got dy dx here, minus 2 is equal to 0. Do we agree on that? All right, so product rule there, derivative of the first piece is just, derivative of x is 1, so 1 times y is 1y, plus derivative of the second piece, which is dy dx, times the first, which is x. So that's x dy dx. Then 2y, again, we're not using an x here, so we put the dy dx in. And then we already have the x here, so we don't need the dy dx for the last piece. Does that make sense? Now, we're solving for dy dx, so how do I do that? In order to solve for dy dx, I would simply get this piece equals, now we're going to move the 1y over, and we're going to move the 2 over. Does that make sense? So we're going to move the 1y over, and that becomes negative 1y. And we're going to move the 2 over, and that becomes plus 2. All right, now obviously the negative 1y, we could just write it as negative y, right? Like it doesn't have to be negative 1y. All right. Now factor out the dy dx. What do you get? Dy dx would be x plus 2y equals negative y plus 2. And now we're dividing by x plus 2y, and we're going to divide by x plus 2y, and that will give us our final result of dy dx, jackass, dy dx equals this over this piece, x plus 2y. Okay? Does that make sense? Yeah. All right. So, any questions on that? All right. Now, find the rate of change when x is equal to 30. To find the rate of change, x is equal to 30, dx dt is equal to 20, this is the way you're going to do that. You're going to take the derivative of this piece with respect to t. Okay? So you're going to get dr dt right, equals derivative of this piece with respect to t is going to be 50 dx dt. All right, so it's going to be 50 dx dt. Does that make sense? Minus the 2 is going to come down as the power rule, so 0.5 times 2 is 1, right? So this is minus 1x, and then dx dt, right? So to find the rate of change if x is 30 and dx dt is 20, what do? Well, you simply plug 30 in for x and 20 in for dx dt. Does that make sense? So the rate of change if dx dt is 20 and x is 30, So dr dt would be equal to 50 times 20, and then minus 1 times x is 30 times 20. All right. So what is that equal to? 50 times 20 is 1,000, yeah? Minus 600. So that is equal to 400. Okay. And that's how much the revenue is changing when x is 30, which is like 30 units, right? And dx dt is equal to 20, which is how many units it's changing over time. Okay. All right, any questions on that? Very standard final exam question. And when they give you this information, dx dt equals 20, and I said dx dt, it could be dy d animation, it could be any number of different letters, but functionally it's the same. You never know what to do with it. Okay?
So if it's not dy dx, you know it's a term. You take the derivative to make that.
Yes. Yeah, you take the derivative with respect to whatever the bottom letter is. And usually that bottom letter may or may not exist in the formula. Like if this is 50t, then dx dt would be just 50. Right? But it's not. All right. All right. Elasticity, so this is a demand function. Okay? And just for the purposes of our understanding here in class and at home, so there's a demand function which talks about how much demand is there for a product. And then elasticity kind of refers to this concept, which is if I raise the price of the piece, what happens to the demand? Well, some things you can raise the price as much as you want to and the demand doesn't go away, right? Medicine, for example. I mean, if I know when I had my heart condition, the guy said, you might have to do the surgery twice. And after the first time, I told my wife, I'll never do this shit again. No, I won't do it again. And she looked at me and she said, well, what are the options? And I'm like, well, okay, that's a good point. I mean, you know what I'm saying? Like, I can say I don't want to do it again, but if the option is die or do that, you go like this. Sign me up. Let's do it twice. Does that make sense? Now, my son wants a pair of Kyries. Okay, so, let's say those are $140. Yeah, I might be willing to spend $140. If those are $440, like those stupid Lonzo Ball shoes, screw that dumb shit. You don't need them.
It's got to be a big baller.
You got to be a big baller, right? So this elasticity kind of deals with this concept of what happens to the demand of a product as the price goes up. Okay? And so, like to pause and welcome a student who is, we could say is on time if class started at 10:10. So how do I find the elasticity? Well, the first thing you got to know is this is a formula for it. Okay? And without knowing that formula, you have virtually no chance of getting it right. And some of you are going like this. I've got the formula and I still have virtually no chance of getting it right. But once you have the formula, it's really not that bad. It's just a matter of finding d prime x and doing some manipulations here. So what we have here is elasticity, which we'll call E of x. Okay, we'll call this E of x is equal to that. So if this is dx, what's d prime of x? What's d prime of x? Well, remember that with the square root, what do? It's 2, whatever that square root is on the bottom, yes? right? Times what? What's on top?
The inside.
The derivative of the inside, which is, in this case, -1. Yes?
Yeah.
Let me pause here for station identification. All right. This is -1 over 2 square roots of 600 minus x. Again, if you needed to see that and you don't remember that, you would write 600 minus x to the 1/2, right? Then the 1/2 would come out front, and you would drop this by 1, right? Then the 1/2 would come out front, and then you would drop this by 1. And that would be raised to the -1/2. Yes? And then you would do the derivative of the inside, which is -1, because the derivative of 600 minus x is -1, right? So that would put this piece on the bottom. That would put this piece on the bottom. And that's, you would get the -1 on top and the 2 square root 600 minus x on the bottom. Okay? Now, once you have that, it's just a matter of taking this information and plugging it in. What do we got? We've got, to use the formula, we've got e of x equals -x times what? Times this piece, right? Just loving copying and pasting, baby. All right, so it's -x times d prime of x, which is this piece, all over what? All over d of x, which is all over this piece. All right. Now, if you do a little bit of simplification here, here's what you'll notice. Negative times negative is positive, yes? So this is really just x over jk, x over 2, the 2 from here, and then 600 minus x, 600 minus x. That will just become 600 minus x. Okay? If you need to see this worked out, because some of you are like, yeah, look, I don't know what the hell you just did. But if you say it, I'll write it down like it's true. If you need to see it worked out, do this. Put this over 1. Right? And then remember that when you divide fractions, you multiply by the reciprocal. So that what you really have here, if you need to see it, what you really have here is simply x over 2 square root 600 minus x divided by this piece. Does that make sense? Which, when you do that, would become this times flipping this over, right? Times 1 over 600 minus, does that make sense? Which would get you to this final part of x over 2, and then these would combine together as 1. Does that make sense? I think sometimes when I just do it from here and say the final answer is that, you're like, whoa, okay, sounds great, cool. If he says so. On the final exam, we pick C. All right. So, and then that would give you a final answer of x over 1200 minus 2x. Does that make sense? And that's called elasticity. Okay. When the elasticity is less than 1, that means it's still, the revenue is still growing. You're making more money. All right. When the elasticity is equal 1, you've maximized revenue. And that's obviously always the goal, is to set the price so that you don't outsource the demand, but yet the demand doesn't drop either. Okay? And then if it's more than one, then it's not good. Your revenue's going down. Okay? Better drop the price of those big baller shoes, baby. Any questions on that? All right, we're going to stop this one.